All right, continuing with our notes, this is video 2, and these notes are right on the back side of the first notes that we took. So we want to remind ourselves how to solve systems by graphing. So anytime we want to graph a linear function, what kind of equation do I have to have? Okay. Hopefully you're answering me at home and laughing at yourself or talking to yourself, but you need y equals mx plus b form. Okay, that form, in case you have forgotten, okay, this is slope-intercept form. All right, once we have slope-intercept form, we want to plot the y-intercepts and use slope to graph. We will make sure that we connect our points with a line and find the intersection. Now once I found that intersection, that is an ordered pair. So we're going to state the solution as an ordered pair. Alright, so steps that I think you can follow and that you can pretty much do in your brain. Okay. So let's look at number 1. Okay, all of these examples here, except for number 2, you have to move around your equations. So I'm going to work with this first guy. I'm going to do my work kind of off to the side here. So I'm going to have a negative 2y equals a negative 2x minus 8. I have to move that x to the other side. I'm then going to divide each part by 2 and a negative 2 and simplify my equation here. So this is the equation of the first line that I get. Y equals x plus 4. So let's plot this. We have a y-intercept of 4 and a slope of positive 1. And when we're graphing a system, I would make a ton of points so you can easily see where this intersection is going to take place. So there's one equation of my line. I'm going to work on this second one here. That's going to be 2y equals a negative 2x plus 4. I move that x over. Divide each piece by 2. Scroll up here a little bit for y'all. I'm going to get y equals a negative x plus 2. So again, I'm going to plot this point on the same graph. So my y-intercept of 2, and now I have a negative slope. And my point already crossed, so I'm going to make this line a little bit shorter. I have found that point of intersection. Where these two lines overlap, that is my solution. That is at point negative 1, 3. That is my answer. I'm going to go diagonal and do number 4 as well. So if we look at number 4, my first equation is y equals 5. What kind of line is y equals 5? Hopefully you said horizontal. So here's where y is equal to 5, and I'm just going to draw in a flat line there. I am going to have to solve for y in this equation. Again, I'm going to do it off to the side. It's be y equals a negative 2x plus 1. And luckily for this equation, just by moving that x, I got y totally by itself. So let's plot our y-intercept at 1. I have a negative 2 slope, so I can go up 2 and to the left, down 2 and to the right. And again, I found that point of intersection so I can make this second line look a little shorter. Where those two lines intersect is my solution to my system, and that point is at negative 2, 5. Go ahead and pause the video and try example 2 and 3 on your own. Alright, I hope you took my advice to pause the video, because here's the answer to number 2. I have the same slope. If I have the same slope, I'm going to have parallel lines, and that means I have no solution. Here's the answer to number 3. I had to graph this equation in blue. When I solved my second equation, I'm going to leave that answer, that slope, as a fraction, so I can count rise over run a little bit more easily. That point of intersection is at negative 3, 1. Now let's look at the fill in the blank options here. Good test questions, good reminders for y'all. If the lines have the same y-intercept, the same slope, then the system should say has infinite solutions. You're graphing the same line, so every point on that line will be a solution. If the line has the same slope and different y-intercepts, okay, same slope and different y, then the system has no solution. Same slope and different y tells me I have parallel lines. That is no solution. If the system has just straight up different slopes, y-intercept doesn't matter, then that system has one solution, or one intersection. Feel free to be dangerous and try some more of these graphing problems in the next few pages of your packet. But we will practice graphing in class tomorrow and even move on to substitution.